Good morning, everyone, or good afternoon. Today we are going to finish up our Unit 3 and take some notes from our anchor charts on not proportional linear relationships. All right, so you'll see that this set of anchor chart looks very similar to the one we did for proportional. So now we just kind of switched everything around so that it fits our new topic, not proportional. So to get started, the equation for not proportional is now, instead of k, it's mx plus b. So m is now takes the place of our slope variable, and b represents our y-intercept, which is our new concept. X and y in our equation, again, represent all points on the line. Oh, got to add an S there. And then our equation, k equals y over x was proportional. When we do non-proportional, m equals the change of the y and the change of the x. So we put the triangles in there so that we know that we're looking, and we might have to do some subtracting in order to figure out. We can't start at 0 and just count up or over. We have to make sure that we're getting the right chunk of data. Okay, again, y-intercept is our b variable, represented with a b, and this is where the line crosses the y-axis. So here's our example of an equation. Y equals 4/3 x plus 2. Our slope is 4/3. So that means we go up and we go over 3. And our y-intercept is 2, which means we're going to be starting on the y-axis. We're going to go up to the 2 on the y-axis and put our first point there. All right, taking a look at the graph. Graphs that are not proportional do not go through the origin 0, 0. So you can see here in the description, in the picture, that we are not starting at the origin. We're actually starting, this one's starting at 2, so 0, 2. So non-proportional relationships do not start at 0, 0. So that's kind of showing you right here. Your y-intercept is also known as the vertical intercept. Those words can be interchanged, so you should know both vocabulary words. And in this case, our vertical intercept, based on here, we go up to 0, 2 is the ordered pair. The y-intercept is 2. Again, as normal, we find slope by rise over run. So if we take a look at our table and we do a rise over run, we're looking to see how far up we go and how far over we go. So in this example here, we look at our scale. We're counting by 1, so we're going from 6 to 10. So 10 minus 6 is 4, so we're going up 4. And then how far we're running, look at our scale again. We start at the 3, and we're going to the 6. So to go from 3 to 6, we would add 6 minus 3 is 3, or we add up. So that'd be plus 3. So our slope should be 4 over 3. That's what we're looking for down here. All right, so what happens? How do we find slope the other way? What happens if the graph isn't given, but you're given these 2 points? It's the same thing that applies. We're doing the exact same thing. So we're looking for the triangle. What's a triangle mean? It means the change or the difference in the y, and the change or the difference in the x. Remember, y is on top, x is on the bottom. I saw on the last quiz that's where you made a lot of your mistakes. A lot of you are putting the x on top, so be careful. The y variable has to go first. That's the second number in an ordered pair. Your y variable is the second number in your ordered pair. Those are your y's. So down here, we come down here for our change, our y minus our y. I'm going to start with this one because it's the bigger number, so I'm going to start up here. And I'm going to go 10 minus 6. So 10 minus 6, and that does equal 4. And then I'll take a look at the other 2 numbers. Those are our x values. Oops, I forgot to write that as a y. All right, and because I started with this one, I have to start with this one too. So I'm going to do 6 minus 3 on the bottom. That's the wrong color. 6 minus 3. And if you see, even rise over run, it's the same. You're going to get the same answer for your slope. All right, in a table. So with our proportional relationship, we only had to worry about the x and y, and it was just y over x was our slope. But in this case, it won't work out that way because we'd have 2 divided by 0. You can't divide by 0, and none of these would end up being the same. So therefore, because of this showing you that it is not proportional, you might want to make like a little note to yourself here. Let's do that. Okay, this is your proof in a table that this is not proportional. If it was proportional, it'd be 0, 0. All right, so then we're going to find the difference. So we're going to draw our arrows going down this way and our arrows going down this way. And we're going to find the difference of the y's and the difference of the x. So let's go ahead and start with the difference of our x's. To go from 0 to 3, it's basically 3 minus 0. That's a change of 3. To go from 3 to 6, that'd be another change of 3. Remember, you can always subtract if you need to. 3 minus 0, 6 minus 3. This one would be 12 minus 6, so that'd be a change of 6. So feel free, you can write those down on the side just so that you can see that, yeah, you are subtracting the difference of the y's and the difference of the x's. Okay, let's go ahead to this other side. So we would do in this one 6 minus 2. So that would be 4. And then we do 10 minus 6, which would be 4. And then we would do 18 minus 10, which is also 4. Oops, 8. Sorry. 18 minus 8. Where's Mrs. Meyer at? Math, Mrs. Meyer. That's an 8. All right. So I could do the math on the side, so showing you that I'm subtracting, get my numbers. Now I can very easily put them into my table. The change in the y over the x. This would be 4 over 3. There's my slope. 4 over 3. There's my slope. Can't simplify that. And the last one's 8 over 6. That one I can simplify. I can divide these both by 2, and then I would get 4 over 3. So again, my slope is, let's go with this color, 4 over 3. Same slope. All right, so there's our table. And lastly, just some things as reminders about non-proportional relationships. First of all, a triangle means a change or the difference between two numbers. The equation y equals mx plus b is called the slope-intercept form. And why is it called that? Well, what two things do you need to write the equation? You need the slope and you need the y-intercept. So that's why it's called slope-intercept form. The y-intercept represents the starting point in a situation. Where are you starting? Where are we starting if we're graphing it? Where do we start when x equals 0? Or in this case, we have no weeks. Where am I starting at? Okay, at 0 weeks, I'm starting at the 2. Okay, on the starting point. So where are we starting before we apply any of the slope? All right, and then in our last part here, we're talking about in this situation, what does our slope of 4/3 really represent? So just a little reminder, this was our slope. So what does it really represent? So when we look at our 4 is over here. It's how we went from 6 to 10, and the label for this is dollars. So what does this really represent? The 4 represents $4. And then if we look at the 3 goes across here. It's from the 3 to 6, and that in a situation represents weeks, 3 weeks. So putting this all together, in Jill's savings, because this is her piggy bank, so obviously she's putting money into her piggy bank because Her piggy bank is increasingly getting more and more money as the weeks progress. So Jill saving $4 every 3 weeks. And if it was 1 week, you'd say $4 each week. Could be the change of that terminology, or every 1 week would work too. So making sure that you have what the label represents in front of your number and the word every or each, explaining to me what the situation means. Some of you are still missing out on some of this technical on how to word it in your sentence. So make sure you're pulling that information off your labels and making sure you're looking at your title or the situation to figure exactly what it means. Okay, and one last thing just to kind of review. Right here, ladies and gentlemen, is, you know, the formula for 2 points. So let's just write that on the side here. So if you are looking and you're doing a problem for your review, this is exactly how you find slope from 2 points. It's the very first part of our song. So I'm going to also, for the fun of it, put a little music note here, and I'm going to write the difference of the y and the difference of the x, and unmusic note here. Okay, so that you know that that's the first part of the song. So if you say that part to yourself, you're going to take the difference of the y's, the y values, subtract them, the difference of the x values, subtract them, and you'll get your slope. As easy as that. You don't even need a graph in order to do the 2 points. All right, so that should be everything for proportional relationships. Go ahead and glue this down into your interactive notebook, fill out your table of contents, and good luck reviewing. See you later.